Hi guys, Mrs. Pender here to walk you through your opener. So we are going to graph this rational function using this handy dandy note sheet with step-by-step instructions. What I'd like you to do is go ahead and pause the video and start the process. And if you reach a point where you have a question, stop and maybe turn the video back on and watch. But see if you can get all the way through to the end on your own and graph this function. Okay, so if you're feeling confident, you're going to pause me now. If you feel like you need to watch the step-by-step process, here we go. All right, so I'm looking at my note sheet. And step number 1 says to simplify the function by factoring, if possible, in order to identify any holes. So you are looking for numbers that multiply to -40, and the same two numbers add to 6, so that you can go through the factoring process. I will tell you that after you do so, your factors are 5x minus 4 and x plus 2. The denominator is a little bit easier. It's the difference of two squares, x plus 2 and x minus 2. Now, at this stage, when the function's factored, we're looking for holes. I can see here this common factor of x plus 2. That's going to create a hole in the function at x equals -2. And my new improved function is 5x minus 4 over x minus 2. So this is the function that I'm going to work with for the remainder of the steps. I don't look back to the original function. I focus on this simplified function. Here goes. Step 2. Find the y-intercepts by evaluating f of 0. Well, that would be 5 times 0, which is 0, minus 4 over 0 minus 2, which is 2. So my y-intercept is 0, 2. Step 3, find the x-intercepts by taking the numerator and setting it equal to 0. So if I set 5x minus 4 equal to 0, my x-intercept will be 4/5, 0. All right, I'm on step 4. Step 4 is when we use the denominator of the function to identify vertical asymptotes. So I'm going to have a vertical asymptote at x equals 2. Horizontal asymptotes. So here I have to look at my function and ask myself the question, what's the relationship between the degree of the numerator and denominator? They are the same. The degree of the numerator is equal to the degree of the denominator, and so my horizontal asymptote is going to be y equals the leading coefficient of the numerator, which is 5, over the leading coefficient of the denominator, which is 1. 5 over 1 is 5, so I'm going to have a horizontal asymptote at 5. I'm going to go ahead and start to construct my graph. So, use a set of axes here. And I will go ahead and plot my asymptotes and my intercepts. So let's see, I have a y-intercept at 0, 2, an x at 4/5, 0. A vertical asymptote at 2, and a horizontal asymptote at 5. It looks like I might want to increase my axis a little bit up here. I'm going to go ahead and extend this as far as I can. So 2, 3, 4, 5. Here's my horizontal asymptote. All right, now, I need some more points. This is not enough points to determine what my function looks like, so I'm going to create a table of values, and I'm going to make sure that I have at least one, but sometimes more than one point to the left and the right and between any intercepts and asymptotes that exist. So I want something to the left of this point, so I'm gonna pick up maybe -2. Something in between here, so maybe a half. Something in between here, so maybe 1.5, and then a couple of points over here. So I'm gonna make my table of values. I'll make my table over here. I think this is a safe place for it. So I'm gonna choose some x values, and I'm gonna put them into the function and see what I get. Here goes. So I'm gonna choose, I think I said I was gonna choose like -2, and then +1/2, 1.5, and then I'm gonna do maybe 3, 4, and 5 to make sure I have enough points to the right of that asymptote. So these points are gonna get subbed into this function. Just be careful. This is sort of the tedious part of the process, but it's manageable. Just take your time. Sorry about that, I had to leave for a minute, but I am back now. So I'm going to start creating my table. And I'm going to put these little guys into the calculator. Let's see here. So all right, at -2, I have 3.5. At 1/2, 1. At 1.5, -7. 3 is 11. 4 is 8. And 5, I have 7. So let's start putting these points on. Let's see. -2, 1, 2, 3.5. 1/2, 1. Pretty clear to see what's happening in this portion of the graph. So we're coming down off of the asymptote, curving over, and then approaching the vertical asymptote. There's one piece of my rational function. And I'll continue adding my points. So at 3, I was at 11, which is way up here somewhere. Let's see. 5, 6, 7, 8, 9, 10, 11. And at 4, I'm at 8. And at 5, I'm at 7. And so now I can start to see the second portion. Again, it's going to sort of come down off of this vertical asymptote, curve around, and then approach the horizontal asymptote. Now, don't forget that in our very first step we said there was a hole at -2. So now I'm going to go over to my graph to -2 on the x-axis and move vertically. And I'm going to erase a little area here and insert a hole into my function at -2. So there it is. My rational function is graphed with enough appropriate points to see the picture of the curve, and I have inserted my hole.